Welcome back to the Learn How to Use WonderLogix Studio training series. In this episode, we're going to continue building our water supply system. And as a reminder, here's a review of our project description. And in this episode, we'll be putting the level transmitter in the water tank and then hooking the water tank and water well together with our logic editor in order to get the functionality that we desire for our project. Okay, let's go into the water tank. And now we need a transmitter in here, right? We had our level transmitter, so let's go to our classes and let's add a new transmitter. And according to our drawing, we're going to call this level transmitter. And we're going to give this a tag and double click the name, give it a tag here of LT201, save. Okay, and now it's time to answer the question from the end of our last episode about which logic connector we might use, because we're going to hook up the reading of our level transmitter to the filling required output on the water tank. Now, logic connectors within WonderLogix usually follow this pattern. So here's an example sentence where we want to operate a motor, and then one of these four logic choices: only while a button is pressed, or from the moment a button is pressed, or just once when a button is pressed, or always. So the structure of most of these logic sentences is some action that you want to take place, a connector that connects it to a trigger, something that sets that action off. Right? So we want to operate the motor as the action. Only while is our logic connector, meaning under what condition, and then the trigger is some button was pressed. So only while something takes place, right? That's an action that takes place if and only if the trigger is true, right? So I want to set this condition to be true. I want the motor to run only while the button is pressed, right? Press the button, the motor runs. I let go of the button, the motor stops. If I say from the moment of, then in this case, this is where we have to set a condition and then clear a condition. So from the moment that I push a button, even if I let go of the button, I want something to occur. And then at some point, I want to be able to clear that. Maybe I have to push another button or cross another condition. Then I want to clear the action that has taken place. And then there'll be a resolver sentence that says, well, what if you receive both buttons, right? What if there's a start and a reset and someone presses both, or you have a short in the line? And so the system thinks that it's receiving both signals at the same time. You want to be able to say what to do if there's a conflict. Just once when. This is a momentary connector. We use that for things like on a reset a counter, right? So maybe it's just once at 7 p.m. at the start of the shift, reset the shift counter. Starting a sequence, now it's time to start this particular sequence in your batch process. Or, we want to copy a value from some logic that's going on over to the end of some other sequence. These are things that are done within the logic inside the PLC. And always is always. There is no trigger condition. It's just something that always is that way. I want this to always be on or always be off. This is also used as direct logic tied to analog inputs and outputs, for example. So for example, I want the analog input of a knob, this value, this parameter I'm going to hold to always be tied to whatever that knob value is coming in. So it's just always set that way. So let's see which one we need in our situation. So in our case, we want to take a look at the reading and decide if filling is required based on the percentage full of the tank. So because we want to be able to turn the pump on if the level drops below 40 and turn it off once it reaches 60 or greater than 60, then we have two separate conditions. So for that, we're going to end up needing the from the moment connector here. See, the action takes place the moment the trigger turns true until an opposite or different action is taken. So we're going to need from the moment. So let's see how to do that here. We're going to say the water tank will report the filling is required. Instead of only while, I'll have to say from the moment that the reading of the level transmitter is less than 40%. And we'll accept that sentence. And then since it knows that that's going to report that the filling is required, it wants to know when to clear it, right? So it's the same as when it sets. It needs to clear, so we're going to clear it from the moment that the reading of the level transmitter is greater than 60%. And so you can see here that the logic editor, once you've used the from the moment to set a condition and clear condition, that the conflict resolver sentence will pop up asking you if it were to receive two signals at the same time, which one should it follow? And you always want to choose the safe option. In this case, since we're only using one signal, the level transmitter, in this case, we can't get two different signals at the same time. So for this, it doesn't matter which option you pick in the conflict resolver, but it's good practice to still always pick the safest option, especially since later your logic might change and make use of an additional signal. And in that case, you will already have the safe resolution option in place. So even if it's not really needed, such as in this case, picking the safest resolution in the case of a conflict is a good habit to get into. And if you ever get these in a different order, you can always grab one of these and rearrange them to make them better order for you. Usually we recommend that you keep these in the order that makes sense, that you first set a condition, then you clear condition, and then if there's a conflict, how do you resolve the condition? So let's review what we have here. The water tank report that filling is required once the level transmitter drops below 40%, and then it'll clear that filling required condition once it's greater than 60. Okay, so we can go back out to our main level here. And our system is now complete. The water tank knows its conditions for when it needs to ask for water. The water well knows when it needs to operate, and it knows when to report a failure. Now, coming up, we're going to have our first change order in our next episode. And in that situation, we discover that the level transmitter that we just set up is sometimes not giving reliable readings. And so sometimes that the water was overflowing from the tower because the pump didn't shut off when we thought it should. So just think, is there some sort of device or some condition we could use in the water tank to help as a double check, as a safety, so that that wouldn't happen? What kind of device might that be? We'll find out in the next episode. Okay, that's a good stopping point. We'll see you in the next lesson.